My name is Devin Hubbard. I'm a faculty member in the UNC and NC State Joint Department of Biomedical Engineering, and in early March of 2020, I partnered with UNC Healthcare and some groups on campus as well as local industry to work on some PPE-related projects. Specifically, I was in charge of masks. We worked on everything from high-performance respirators to basic surgical masks, and we also partnered with industry to work on projects for protecting our healthcare professionals in between. The result of that work was 12 different mask designs and a startup company. In fact, the product around my neck is made by that company. So I'd like to walk you through kind of some of the different projects that we did and the results of them. Okay, let me talk about the different projects that we did. And before we get there, I think it makes sense to talk about what masks are designed to do. So a basic surgical mask like this one, that most folks are probably familiar with, these are really just designed for splash protection and to capture particles that are exhaled, or at least block them and redirect them. On the far extreme here, we have a respirator. These are designed to protect the wearer from inhaled aerosols. The way that these function and the reason that they work to protect the wearer has to do with three things. So the first is this material, which is pretty much the case for all of these, is able to capture small particles, in particular the ones that we are looking at. So because the material is able to capture them, they're supposed to be able to protect the wearer. However, that only matters if it also fits really well, which actually turns out to be a challenging problem to solve. So for reference, a pinhole in an N95 can actually cause it to fail and not protect the wearer. The particles we're talking about here are very, very tiny. And so respirators actually feature a very tight fit specifically because you want all the particles to be forced through the material. The last thing that you have to have in order for a mask to protect the wearer is actually enough of that material. That has to do with the amount of force required to breathe in. If you don't have enough material, it's kind of like breathing through a coffee straw. And it's very difficult and it requires a lot of effort. And that additional effort and force can actually allow particles that wouldn't normally get through to sneak their way around little gaps in the edge or sneak their way through the material. And so it turns out if you have a good material and a good fit and there's enough of the material for it to be breathable, you can protect the wearer pretty well. Now, the question arose pretty early on as supply chains were drying up, like what do we do if we run out of N95s? So one of the projects that we were working on is converting existing masks and mask materials into something that fits really well. It turns out that fit is the feature of most masks that is the failing point, at least for ones that are in the medical field. So in the middle here, you can see I've got a surgical mask, and this is actually sort of an in-between. Now this mask is made and prototyped in conjunction with a really large clothing company in North Carolina. This mask features a material that's made over at NC State in the Nonwovens Institute, specifically designed to capture these high-risk particles. And it's manufactured to fit a little bit better. Now, this doesn't quite achieve the performance and fit of a respirator, but it's certainly a lot better than what you'd find in a regular medical surgical mask. This ultimately, after many iterations of design, ended up turning into a product that is now actually being used and sold on the market. It's been approved by the FDA for emergency use as a face protector. And then on the far right, you can see, I guess this might be your left, but on this end, you can see that I've got masks that are what you're probably used to seeing in a surgical suite or just in medicine in general. These are designed to protect the wearer mostly from splash. And they're made out of the same material usually. So interestingly enough, the material that's used in most surgical masks is very similar, if not identical, to what's used in an N95. It's usually a non-woven polypropylene. So the cool thing about these is they actually filter really well, but because they don't fit particularly well, the result is particles sneak their way around your cheeks, around your nose bridge. If you wear glasses, you'll know they fog up because there's leaking here. And sometimes they leak around the chin. And so one of the projects that we were working on was figuring out what do we do if we run out of N95s? Well, we had this good material from NC State as well as from these surgical masks. We thought, well, what if we just make it fit better? So early March, we started prototyping ways of making these masks fit better, and that's where this comes in. This is a mask fitter that we designed and actually ultimately turned into a startup company, and you can see basically its function is pretty straightforward. All it does is close the gaps between your face and the mask, and this material that I'm wearing is high performance enough to capture materials, but because this mask didn't fit before, things were getting around. But now that I'm wearing a mask fitter, it turns out that I'm definitely capturing more particles in this. In fact, we did some testing with this with the EPA, and it turns out that under the right conditions, when this is fit correctly and using the right materials, you can actually perform at least as well as an N95. Now, that's not always the case, but it was very encouraging to us. Great. So this particular design is, as simple as it is, actually thought out very carefully. We spent a lot of time considering the environment and the features that were critical to this. This is called an airframe, but it's basically a mask fitter. Namely, it was designed in conjunction with infection prevention protocols, amongst other things. So one of the features, for example, like this is latex-free elastic, which obviously you don't want these sorts of things causing allergic reaction. Importantly, this device is also designed to go over your head, just like an N95. So the sizing of these frames are also designed to mimic the existing size, because the original intent was that these would go into the healthcare setting where most folks know their N95 size, or at least they're familiar with their face shape. And so these are designed to kind of mimic the existing N95 sizes. The other is that when you're removing a mask with infection prevention, you don't want to touch the mask. And so we engineered this so that when you remove it, it comes over your head and you're not touching your mask or your or the airframe as you remove it. And you may actually see that there's actually little hooks on the airframe. It turns out you can connect the ear loops of a standard procedure mask like the one that I'm wearing to the airframe, so that when you remove it from your head, it brings the mask with it. And the reason for that, again, is if you're trying to not touch your face, which could be contaminated with pathogens, by removing it this way, you don't have to worry about it. The other thing that I'll mention about this is that the material chosen here is designed specifically so that you can clean it. This plastic is recyclable, and you can clean it with harsh chemicals. You can actually even autoclave it. All those things were designed specifically, again, so that we could take it into a healthcare setting. So yeah, the fitter is designed to kind of accommodate a variety of face shapes. It's designed to go in an environment like the healthcare environment specifically. And yeah, so we spent a lot of time going through product iterations and getting feedback on it so that we could make sure that it was catering to the environment and to the people that were going to use it. And so we worked, like I mentioned, we worked on a variety of projects. This actually was about 12 different projects. I think we ended up with over 100 different prototypes of masks and mask designs and fitter designs that we went through. And the last of them, well, not the last of them, but certainly the one that I want to talk about last is these pediatric masks. So at one point, pretty early on actually, the supply chains for masks were drying up, and one of the concerns was, what do we do when we run out of pediatric masks? Just like every other mask, pediatric masks were in high demand and short supply. So we got asked by UNC Healthcare if we could figure out a way of converting an existing surgical mask into something that could be worn by a kid. And if you look at the designs for children's masks, they're basically just shrunk down versions of an adult mask. Well, it turns out that these materials that are used to make these masks are plastic most of the time. And plastics melt really nicely. And as a result, you can actually just use a heat sealer to manufacture, with some clever folding and some heat sealing, a pediatric mask that fits really well and actually fits the dimensions almost exactly of an existing pediatric mask. So I'll show you a little quick demo of how we make these, which is kind of slick. Cool. Let's talk about how we get from a surgical mask like this to this. I should correct myself. This is a procedure mask. Let's try that again.
Okay, just keep rolling.
Okay, so let's talk about how we get from a procedure mask like this to a pediatric mask like this. So I've got a heat sealer here. Now, these are normally used for sealing bags. Like if you're putting product in a bag and you need to seal it, this is what you'd use. So obviously in a pandemic scenario, we were working on a very lean budget and a very tight timeline. So we just kind of used what we had on hand. So normally this wouldn't be done with a heat sealer, although you can. Normally we'd use something called ultrasonic welding or RF welding. But for this, it works really well, and this is easy to train somebody on. So what we did was we figured out that the approximate dimensions of a pediatric mask can be mimicked by just making a couple of folds. So if you fold the ear loop side over just along its seam, and then throw it in a heat sealer like this, all you have to do is bring this down, and we can heat seal along that edge. Hold it there. I'm doing this very slow. I might add we recruited a lot of graduate students that could help out with this and undergraduates as well who volunteered to make this. We made a couple thousand of these and delivered them to university. You can see this made a nice seam along here. We'll do the same on the other side. So we had students that were working kind of around the clock during the week that came in and followed very careful protocols to make sure that they were containing any infection and that they were working in a clean environment. And so we had set them all up with these heat sealers down in our design lab, actually, which is really cool. And they spent days manufacturing these and boxing them back up, which worked out. And they used them in the pediatric hospital. So you can see I've got two seams here. That's made the entire mask shrink this direction. And now what I need to do is bring the chin up. And so to do that, I'm going to make one more fold, which is this direction here. And then we will come in here and seal that as well. So let's do this last one. That's nice and straight. Alright, so now I've got my mask. And so you can see I've sealed on 3 sides, and now it's about the same size as the other mask. So this is an adult procedure mask, this is a pediatric one. And basically it works the same way. You can still unfold it, you can still use the nose wire, and this works really well. And so we actually delivered a bunch of these to the UNC Healthcare Pediatrics Hospital, and they used them. Cool, so at this point, you know, it's been almost a year and a half since we did all this work, and there's been a ton of progress. I think it's important to acknowledge here that none of this was done just by me. We had an incredible team, incredible team. Really awesome network. We worked really closely with other groups on campus here, a bunch of other engineers. We even worked with other universities. We worked with the governor's office. We worked with companies in the area. So this is a really huge team effort. I was just kind of part of it. At this point in the pandemic, luckily, supply chains have gotten a little more reasonable from the PPE perspective. So luckily, we are no longer having to manufacture these. But I can say that we have, as I mentioned earlier, started a startup company that's now producing these mask fitters. They're available right now, which is nice. And the good news is that the health systems are able to now keep up with personal protective equipment, which is ultimately the most important thing. For me, these projects were just an incredible opportunity for me to learn something new. I had very little experience in this field before, and so for me, I got to learn a ton. I feel very lucky that I've been able to meet some of the great people that I'm working with now, and to have done some of the incredible work that we were able to pull off with very lean resources and very tight timelines. So it was very much a pleasure.
You want to try it one more time?
Sure. Yeah.
Okay, let's do it one more time.
I don't really know what you want me to say, I guess.
Well, just that was fine. Should you mention the name of your startup?
I can. I don't know if I'm allowed to, but I'll do it anyway.
Okay, well, that's totally up to you.
Well, it's really, I think it's fine. I'll just do it. Whatever. YOLO.
Okay.
If the EPAP and COI people come after me, I'll just be like, oops.
Forgiveness, not permission.
Yeah, that's right.
All right, whenever you're ready.
So at this point in the pandemic, luckily, the supply chains have sort of evened out. And UNC Healthcare, at least to my knowledge, is no longer in urgent need of personal protective equipment, which is great. But going forward, I mean, first of all, none of this work would have been possible without an incredible team. We got the opportunity to work with, obviously, UNC Healthcare and all their affiliates. We got to work with a ton of different healthcare systems in North Carolina. The governor's office was involved. We worked very closely with other engineers and other departments here and at other universities. And I got to meet some incredible people and work with some incredible teams. And obviously, part of that was also corporate North Carolina that helped out with some of the manufacturing design early on. Going forward, we started a startup company called Aram Innovations that makes these mask fitters. Those are actually on the market now, which is really cool. So for me, that was an incredible experience as well. And so for me, I mean, it was a really great honor to work with a whole bunch of wonderful people. I think it shows what we can do on a really short timeline with a really, really tight budget and with some volunteer time and just sort of effort. So for me, it was an incredible learning experience. I didn't know a lot about personal protective equipment or masks before I started these projects, and now I feel like I have a really great grasp on it, and none of that would have been possible without all the wonderful resources that we were given. So I think it was a wonderful example of how folks can step up to do some incredible things with very lean resources in very tight timelines. So for me, it was a fantastic honor, and I'm very glad I was able to work on it.